Hey everyone, this is your host. Today we're going to answer an interesting question that I got from one of our viewers. Why do wind turbines have 3 blades? If you enjoy learning about the science behind everyday things, make sure to subscribe so you don't miss out on future episodes. When most people think about wind turbines, they imagine large structures with 3 long, thin blades rotating slowly and steadily to harness the power of the wind. But why exactly is it 3 blades and not 2 or 4 or some other number? It might seem like a simple question, but there are actually 2 main reasons why wind turbines typically have 3 blades. The first reason has to do with how much torque the blades can generate from the wind without creating too much drag. Let's consider a wind turbine with only 1 blade. When wind flows over this turbine, it will spin because the shape of the blade is curved on the top and flat on the bottom, much like an airplane wing. This means that the air moves faster above the blade than below it, which creates a low-pressure area above and high-pressure area below. The pressure difference then generates a force that makes the turbine turn. However, a single-blade turbine is terrible at collecting energy from the wind. As the wind passes over the blade, it's pushed downwards, which slows the wind down and reduces its speed. So as the wind turns the blade, it loses energy. This is called drag, and we want to minimize it. Now let's add another blade to the turbine. Now when the wind hits the blades, it's split into 2 sections. On the right side, the wind moves faster above the blades and slower below them, creating lift. On the left side, the wind moves slower above the blades and faster below them, also creating lift. The 2 lifts add together to make the turbine rotate, but now there's a problem. As the wind pushes down on the right side of the turbine, it also pushes up on the left side. This creates a pair of equal and opposite forces that make the turbine twist as it rotates. A lot of torque is good, but too much can damage the wind turbine. Modern turbines need to be able to handle high amounts of torque without breaking apart. For this reason, engineers usually try to design turbines with multiple blades to cancel out any unwanted twisting forces. So let's add another blade to see if we can get rid of the twisting force. With 3 blades, we still have lift on all sides, but the forces balance each other out and there's no twisting force. This means that a 3-bladed wind turbine can capture more energy from the wind than a 2-bladed turbine without breaking itself. In fact, by adding even more blades, we can increase the amount of torque generated by the wind turbine. However, we also increase the amount of drag. So there's a trade-off. More blades mean more torque, but also more drag. To understand the trade-off between the number of blades, torque and drag, we can look at this graph. The horizontal axis shows the tip speed ratio, TSR, which is the ratio of the linear speed of the blades tipped to the speed of the wind. The vertical axis shows the power coefficient, CP, which is a measure of how efficiently the wind turbine converts wind energy to electrical energy. The higher the value of CP, the more efficiently the turbine is converting wind energy. Each line on the graph represents a different number of blades. As you can see, the optimal number of blades is somewhere in the middle. Too few or too many blades reduces the overall efficiency of the turbine. In general, turbines with fewer blades perform better at higher rotational speeds, whereas turbines with more blades are more efficient at lower speeds. This is because, at lower speeds, the air moves more slowly relative to the blades, so the lift generated by each blade is lower. To compensate for this, you need more blades to generate enough lift to keep the turbine spinning. At higher speeds, the air moves faster relative to the blades, so the lift generated by each blade is higher, so you don't need as many blades to generate enough lift. Now, for a given number of blades, the optimal speed for the turbine is around 7 meters per second, or about 16 miles per hour. This is why most wind turbines have 3 blades. It's a good compromise between efficiency and structural integrity. We could use more blades to increase efficiency at lower speeds, but then we'd have to deal with more drag and potential structural issues at higher speeds. Using fewer blades would help with the structural issues at higher speeds, but then we'd lose efficiency at lower speeds. The second reason has to do with engineering. 2-blade turbines can experience extreme forces due to the way they extract energy from the wind. As the wind flows over the blades, it creates lift, which makes the turbine rotate. However, because there are only 2 blades, the lift on one side of the turbine does not cancel out the lift on the other side. This creates a twisting force on the shaft of the turbine, which can be very dangerous. If the shaft is not strong enough to handle the twisting force, it can break, causing the blades to come loose and fly away. 3-blade turbines do not have this problem because the lift on one side of the turbine cancels out the lift on the other side. This makes the turbine more stable and safer to operate. 4-blade turbines are even more stable than 3-blade turbines because the lift on one side of the turbine is cancelled out by the lift on both sides. However, 4-bladed turbines are less efficient than 3-bladed turbines, so they are not used as often. In addition to the aerodynamic and structural advantages of 3-bladed turbines, there are also some manufacturing and maintenance benefits. 3-bladed turbines are simpler to manufacture than 2- or 4-bladed turbines. This is because the blades can be made as simple straight lines rather than curved lines. This makes the blades cheaper and easier to manufacture, which reduces the overall cost of the wind turbine. 3-bladed turbines are also easier to maintain than 2- or 4-bladed turbines. This is because the blades are easier to access, which makes it easier to inspect and repair them. In addition, 3-bladed turbines are less noisy than 2- or 4-bladed turbines. This is because the blades are farther apart, which reduces the amount of turbulence. There are, of course, exceptions to every rule. For example, some wind turbines, such as those used in aircraft, have 2 blades, because the extra blade would take up too much space. Similarly, some wind turbines, such as those used in underwater applications, have 4 or more blades to maximize efficiency in specific conditions. So there you have it, the 2 main reasons why most wind turbines have 3 blades. It's a balance between efficiency and engineering. We could have more blades to increase efficiency at lower speeds, but then we'd have to deal with more drag and potential structural issues at higher speeds. And having 2 blades isn't ideal because it can create dangerous twisting forces on the turbine. So 3 is the optimal solution. At least for now. Thank you for watching, and let us know in the comments below what you think we should do next. Should be another episode on aerodynamics, or maybe something on solar power. Please hit that thumbs up button if you enjoyed this episode and consider supporting us through a donation platform. We'll link to both in the description. Until next time, this is your host,